Just give me a thumbs up when you're ready. I'm Doug. I'm originally from Seattle. I've been traveling around Europe for 4 years with my family. They're in Ireland, and so I got to come here. There was a Kyiv Fest over the weekend, which I was invited to come speak at, and I figured, well, as long as I'm in Kyiv, I should stay a while, and I reached out to React Kyiv, and so I'm really happy that they were able to put on this event the same time that I was here, which is awesome, because it's always fun to give back to the community and talk about stuff that I enjoy talking about. And the second part of this talk, I'm actually going to try out some stuff that I'm creating for a new talk, so we'll see how that works. So we're going to do a little experimenting too. So do we have audio? Are we ready to go? We're good. Thumbs up. All right. So I'm Doug. I'm originally from Seattle. I'm a freelancer, so I do developer relations. I do a lot of work with performance, so speeding up the web, speeding up native apps. The reason for this is because slow apps stink, and no one likes a slow app. I lead workshops on performance, stuff on images. I talk about video, some augmented reality, some machine learning. I wrote a book on how to speed up Android apps. If you're interested in Android apps, that's the PDF, so just download it, and that's cool. And if you ever want to talk about performance or developer relations or images or video, like I'm the only Doug Sillars on the internet, so I'm pretty easy to find. So I'm talking about video, and the subtitle of my talk is Video Killed My Data Plan. And the reason for that is my family, we've been living in Ireland, and I'm sorry they're so low. I see a lot of people straining, and some of my content is way too far down on the screen. So, but anyway, I have this sim from Ireland, and I was like, all right, I'm coming to the Ukraine. Like, I'm ready to go. If you can't see it, it's €5 a megabyte for me to roam while I'm here. And so the median web page, just to load a web page, is 1.7 megabytes, right? So we're talking, €8 just to load a web page. You know what's going to happen as soon as there's video on the web page, right? It's going to get ugly, and my children will wonder why we're eating, rice and beans for the next month when my phone bill comes out. Needless to say, I'm not actually using my data plan while I'm here. The other thing is video on the web is growing. This is 2008, or the last 2 years. They changed the data set for 2019, so the data set looks funky, so I didn't add 2019. But more and more websites are adding video. All the marketing stuff is showing that, websites that have video, people stay on the website two and a half times longer, right? People find video really engaging. It really draws people into the web page. And I talked to a lot of people who are like, well, now we're going to have 5G. And when we have 5Gs, we can finally put video everywhere. Unfortunately, not everyone's going to have 5G, so putting video everywhere is going to break the web for a whole lot of people in the short term. So let's talk about video on the web. Web page test fans here. Anyone use web page test? A couple hands. So web page test is this really great tool to measure how fast a web page loads. And one of the terms they have is called the speed index. And it's sort of measuring how fast content shows up on the page. And it's measured in milliseconds. So the median web page in this database of 5 million web pages on mobile takes 7.8 seconds to load. As soon as you add video, we're at 11.5 seconds. So we're talking 4 seconds longer for a web page to load as soon as you add video. And that's not so great. Web pages that have video are bigger, like the median size goes from 1.2 to 7 megabytes. But it's not all video. Like the median web page with video is 2.5 megabytes. The thing about websites that have video is they're usually pretty interactive, so they have a lot more CSS, triple the images, and double the JavaScript, right? Sites that have video tend to have a lot of other interactive stuff going on. So, yeah, we need to make sure that when we're putting video on the web that we're not really, really slowing down our web pages. So I'm looking through all the data, and I'm like, I wonder where all the videos are being hosted, right? How are people delivering this video data? And I was kind of, I was Akamai, Google, Cloudinary, AWS, CloudFront. Yeah, Facebook was number one. And that kind of blew my mind. And if you actually look, 67% of the requests in my data set were from Facebook. That's a bug. It's a bug on Facebook, and we'll talk about that. But when you're delivering video on the web, there's 3 important metrics to look at. And this is actually from a company that measures analytics for video performance. And the first one is, did the video start? Like, that seems sort of basic, but it's also important. Did the video stall? You know, we all know when you're watching a video and you get the spinny disc in the middle, that's frustrating. It leads to abandonment. People don't like videos that stop. And then, of course, it's really important that the video looks good as well. My contention is if we can optimize the delivery of video, make the video smaller, it's going to start quickly because the video is going to be smaller. It's going to not stall because it's going to deliver properly, and it's going to look good. So if we optimize the videos that we're delivering, it's going to be great. There's research out there that people get frustrated when web pages don't load, and my favorite stat is 4% of mobile users admit to throwing their phone when there's a slow mobile website. People get frustrated when video doesn't work too. And so we've got more data. Like, there's all this great data. This is, again, from Conviva. It's based on 16 billion video plays in Q3 of last year. And what's really interesting is, like, on desktop and mobile, between 2 and 3% of videos just never start and never will start. And, you know, some of them are 404s and some of them are 500s. But I think actually most of it is, oops, it's not available in your country, right? We've all seen this. I see it a lot more now that I'm not in the States and going back to web pages that I want to see in the States. This is a U.S. Website, and, you know, oops, it isn't available in your country. The Amazon application for video is really good about this. If I have an account in America, I fire it up in the Ukraine. It's like, oh, you're traveling. We can't show these videos while you're here. You can watch them when you get back to the States. Here's the stuff you can watch while you're in the Ukraine. It saves me from clicking a button to get an oops, right? They've stopped that. They've cut that, you know, that path off. If you open this up in DevTools, in the back you can't see it, but it took 231 requests and 3.1 megabytes to tell me oops, right? That's 15 euros. Right? That's a lot of money. I mean, that's just kind of, I mean, it's not a good user experience just across the board. The other one that kind of blows my mind is the orange on the side here. 16% of videos on mobile and 28% of videos on desktop would start, but everyone gave up. Like, 30% of your customers just gave up. And the reason is it takes too long for the video to start up. It took 3.5 seconds on mobile and over 6 seconds on desktop. And you know, like, when you click on something, after a while you just give up, right? This is ridiculous. And there's research on that. Akamai found that everyone will wait 2 seconds. And after 2 seconds, you lose 6% of your customers every second afterwards for video playback. It's different for short videos, and most of the videos that we're talking about on web pages are short videos versus like movies. So if you click on a video and it's a cat dressed up like a shark sitting on a Roomba chasing a duck, after like 3 or 4 seconds, you start questioning like what the heck you just clicked on, and you move on. So people give up on those videos. But if you're watching a movie, like 40 minutes, an hour, what's another 10 seconds, right? You've already kind of knocked out an hour of time. Other neat stats is 20% of the videos are the same on desktop as they are on mobile. So that means that the videos aren't optimized for mobile. They're designed to be delivered to a desktop, and you're delivering it to a mobile device. That means it's going to take a really long time for it to start up because generally mobile connections aren't as fast as desktop connections. Ideally, you have it optimized for mobile and it starts up really fast on both, but that's not the way it is. It's going to look really good on the desktop and take forever on mobile. We kind of understand this with images, right? When you have an image, you serve a different size image for this than you do for a mobile device, right? You serve a different size, and if we look at the size of different web pages, we serve fewer images to mobile than we do to desktop. I've got the same data for video. The first thing is look at that y-axis. The top is 7 megabytes. As soon as I add video, it goes to 70 megabytes. We're talking big data here, or a lot of data, not big data. And if you look out here at the extreme at some of the larger web pages, they're actually serving more data to mobile than they are to the desktop. Why are we serving more video information in terms of kilobytes to mobile than we are to desktop? All right, so we're going to go through some of this. Most of the videos being served are MP4s, right? Kind of the standard video. That's these giant lines over here. TS files are streaming. WebM is another format. We'll talk about that. But most of them are MP4s. And the reason for that is the MP4 works on every single browser except for Opera Mini, right? It works, on Opera Mini just doesn't do video. So we're good. Like 100% coverage, MP4 is always going to work. This is a website in America. It's a baseball website for the Boston Red Sox. And they serve the same video on desktop that they do on mobile. It's 17.6 megabytes. And if we start looking at it, it's 17 megabytes. It's 960 by 540. It's 83 seconds long. It's a recap of a baseball game, and baseball games can be 2 or 3 hours. So that's not so bad. It's 1.78 megabits per second. And that doesn't seem super high, but there's actually this thing in America, and it's only an American thing, is that if you've got a video, cell phone providers, the telecoms, actually throttle all video to 1.5 megabits per second. So this video actually won't play, or it'll stall a lot in America on cellular. So that's a problem. So what can we do? We can make this video smaller. I can downscale, right, 1.37 megabits per second. That will probably play. And the way I did that is I uploaded the video to Cloudinary. It's a cloud-based image and video hosting tool. And then I just said, optimize the quality for me automatically. Just do it for me. And what that did is it lowered the bit rate by lowering the quality of the video, but it's good enough that people are happy with it. The audio is 22 kilohertz. That made the video 13 megabytes, right? So I've already made the video 22% smaller, and now it's going to play in America, so that's good. You could go even smaller, right? You could make it 640 by 360. If people are watching it, it might not look so great this way, but it'll probably look fine this way on a mobile phone. And it goes down to 6 megabytes. That's 60% smaller. So there's lots of different things we can do, and we're going to talk about some of the approaches. One thing that's really funny, Web Page Test found this web page for me. On desktop, it downloads 260K of video. It downloads double that on mobile, right? Why are we downloading more video on mobile? We can look at the this is from Web Page Test. It's the waterfall diagram. It's showing me all the requests. They're WebMs. On mobile, it's downloading the Retina version. Do we need Retina versions of these videos on mobile? The answer is no in this case because, again, here's the source code. Retina serve this version. Default serve the regular version. For those in the back, I apologize at the bottom, but they use CSS to hide the videos on mobile. So even though you're downloading 500 kilobytes of video, even though they're Retina, they hide them because they force the width of the screen to be 1,024 pixels wide. And you might be thinking that my phone is 1,080 pixels wide, but that's with the DPR. My phone actually reports 412 pixels wide, so it doesn't play on any mobile device. All right, other funky things you can do. When you download it, when you put a video tag in your web page, you can set preload equals auto. What that tells the browser is no matter what, here are all the requests for this web page. No matter what, just download the video. We need to download that video to every single person who loads our web page. Have you ever been on your phone and you're like, I don't really want to watch this video. I'm on my mobile phone. I don't want to waste all the data. In this case, the web page decided for you and downloaded it to the tune of 24 megabytes, right? If I was roaming, we're talking 100 euros, right, give or take. Not so great. This is really good if you know someone's going to watch the video. Like if you're 90% sure they're going to watch the video, that's great. Other things, the default is preload equals metadata. And what that does is it downloads 3% of the video so that there's a little bit of video there. If someone presses play, it'll start playing immediately, and then they can download the rest of the video. In this case, this is the waterfall diagram, and video's in green. It's this giant download right there. In this case, there was one request for video, but that one request ended up being 2.7 megabytes for only part of the video, because this web page has a 2.5 minute long 1080p 97 megabyte video for mobile, right? That's a little ridiculous, especially like, all right, well, let's see where it is on the page. You start scrolling and you keep scrolling. The video was here. How many people get that far on a web page on mobile? Nobody. Who watches a video once they scroll that far? Nobody. You should be really careful about this. Like, if it's a big video, you can set preload equals to none, and you would make this web page 42% smaller. It's pretty easy. Auto is great if you know people are going to watch the video. Metadata, if it's a really big video and you don't think people are going to watch it, maybe you should not use metadata. So, there's a lot of things we can do to speed up the delivery of the content on our web pages. One really big thing that's coming around now are background videos. Like, everyone loves a background video. It's loading. This is what the web page does, and it should autoplay. I don't know what's going on here. I've never had to wait that long. Let's try it again. There it is. All right, I must have added 2 slides. All right, so that's really exciting. Now you can see there's this web page. Man, I want to take my kids there. It looks like it's a lot of fun. So I was looking at all these different web pages that had background videos, and most of them named the video like background.mp4. This one was called Steven. So I was like, I'm going to go see what's up with Steven. The video was 5.3 megabytes, but it had an audio track. Background videos are silent. So 5% of the file is completely useless. So we should remove the audio track if the video is silent. That just sort of makes sense. You can't actually just mute it. If you mute the video, it'll still have an audio track that takes up space and it's empty. You actually have to remove the audio track, and it's pretty easy to do. All right. This same video downloads on mobile. You can see it. It's green. It's here at the end. Same video, 5.3 megabytes. That's awesome. Except for they, again, hide it with the CSS. And then they have a fallback image, but they hide that too. So you get this. So the fallback image was 900 kilobytes. So we're downloading a 5 megabyte video and a 1 megabyte fallback, and none of it ever shows up to our mobile users. You just wonder if people even test their web pages sometimes. And those are all hidden. All right, one more background video. This is a website in America. They've changed the background video since I took this screenshot, but it's just as broken. This is the video. That's the beginning of the video. The video is 33.6 megabytes. How many of you sit at the front of a web page like, ooh, I hope that's a video? Maybe not. No, you scroll, right? So if it's 33 megabytes, it's going to take a while for that to show up on the screen and start animating. The video is 27 seconds long. How many of you are like, ooh, there's a video? I'm going to sit here for 30 seconds and watch the whole thing through. Nobody does that. It's 2,500 pixels wide. And it's 10 megabits per second. So you should really resize the video for desktop and maybe even smaller for mobile. If you name it 720p, that doesn't re-encode the video. Sometimes they just write themselves, folks. They just write themselves. So if you re-encode it to 720p, it's 4 megabytes. If you do 1080p, it's 8 megabytes. It's big, but we're talking, it's a little more reasonable than 33. On my mobile phone, it downloaded 17 megabytes, and then Chrome's like, screw it. So it downloaded half of the video. And so, I keep joking video isn't cheap, and I keep, making fun of my roaming plan. This is Garth Brooks' website. He's a country singer in America. And you loaded up his webpage at the beginning of the year, and so that's not my mouse. I recorded the video with my mouse right in the middle. Isn't that horrible? So you can turn on the sound. You can listen to Garth singing. And I have one of those speed up the video extensions, so you can see speed up the video right there so I can watch it faster. If you look really carefully, there's another one right there because there's a background video playing behind the video of Garth Brooks. Okay. So we've got the video of Garth Brooks singing 51 megabytes. We've got the background video at 7 megabytes. He had an album coming out, so we had an animated GIF at 6.2 megabytes. GIFs are big, we'll get to that. But they're all being hosted out of Amazon S3. And, you know, the trick with Amazon S3 is it isn't free. They charge you 9 cents a gigabyte, and we're talking 70 megabytes here coming out of S3. So that means that every single page load costs half a US cent just in S3 to load the web page. So you could imagine, you start getting 10,000, 100,000 hits in a month, you could get a pretty big bill from our friends over at Amazon. So we should think about that. Leave site. I have no idea. My computer just did something weird. All right. All right, so another thing is in Chrome, there's a bug that if you loop videos and they're really, really big, they don't cache, they just reload. They download the video over and over and over again. I opened this bug about a year ago. So the Garth Brooks video happens to be big enough that if I left his webpage open for 20 minutes, I downloaded that 51 megabyte video 5 times. Right. This is actually a bug with a lot of background videos on Chrome. Like if you leave a web page open, right? We all have, how many tabs do we have? Like 40? Like on a good day, right? 100? How many's Android device has a little smiley face in the corner? Yeah, right? It doesn't happen on mobile, but on desktop, if you have a background video, it'll just keep downloading and downloading and downloading and downloading. I left a page open overnight. I'm writing this talk on video and background. I left the page open, and my dev tool said I had downloaded 3-point-some gigabytes of background video over and over. Like, that's ridiculous. So, like, do you really need Retina on mobile? If the video's not going to show up, don't download it. Preload equals auto. If you don't know people, if people aren't going to watch it, don't do that. If the movie's silent, strip out the audio track. Don't duplicate web video traffic, and big files can cost big money. So, like, that all seems reasonable. Streaming video is kind of the solution. I'll post my slides too, so don't worry about that. And so a lot of people are like, well, why not just throw it up on YouTube? And that's a great solution if you have like 1 or 2 videos. But if you put a link to YouTube on your web page, you can get between 700 and 1 megabyte of stuff from YouTube. Just, you know, extra downloads. So this is what it looks like. I have a web page inside the body. I have a link to YouTube. And, you know, there's a link to YouTube. I've got 1, 2, 3, 4 JavaScript files, 3 images, and 2 fonts. And they're all at different domains, so I have to do a DNS lookup for almost all of them. That makes it slow. So if you're doing a lot of streaming, you might think about just rolling your own streaming. And it really isn't that hard. So TS files is HLS. HLS is HTTP live streaming. It's the Amazon, Apple, the other A. Apple's method for streaming. It's what everybody's using today. And I'm going to switch to my Google Slides here, if it lets me. And maybe leave site, cancel. Cancel. Where are my Google Slides? Oh, Chrome is mad at me. Video workshop. All right, here we go. All right, so why would you choose streaming? Let's see if that loads. All right, so why do you want to do streaming? If you use the video tag, you only get one size video in there. There are no media queries. You can't choose different sizes for different size screens. Once you choose that MP4 or that WebM video, like that's it. Like if the network changes, it's going to stall. Or if you get a faster network connection, you're stuck with that slow speed. Video streaming lets you change to different bit rates if you can. You can also do things like have alternate audio tracks and all sorts of fun stuff like that. So what type of video streaming do we have? Most of the time when we're streaming video, it's video on demand. It's usually unicast. So you've got a server sending data through the cloud, and it creates, every single time somebody requests something, it's a new request through the cloud. There's a thing called multicast that a lot of people are working on, and the reason why people are really interested in this is you could imagine that if a World Cup game is on and 40 million people are watching it and you have 40 million connections coming out of your server, that can be a problem. So multicast is this idea where you can distribute it around the world. There's a lot of work on that. I'm not going to talk about that. We're going to talk about unicast and video on demand. Video on demand is Netflix, right? It's how you watch TV shows online. We're not going to get into live streaming because that's like a whole like PhD thesis, and that's, you know, watching football. So video on demand. I'm going to talk about HLS. There's also MPEG-, which is dynamic adaptive streaming over HTTP. That's the standard. That's what we're going to move to. They work kind of the same way. So it's, you know, if you understand HLS, you'll understand Dash and vice versa. So you got a video, and what you do is when you break it into stream is you break it into a bunch of chunks, and they're usually like 3 or 5 seconds long. And so you're constantly delivering different segments or chunks of these video files. And the way they're described is in a manifest. And so the manifest basically says, hey, I've got all these segments, video player, here's where they are. And it looks like this. It's just a text file. There's a bunch of stuff at the top that doesn't really mean anything. And then this is describing the first segment. It's 5 2/3 seconds long. That's the byte range, and there's the file to get the byte range. There's the second segment, there's the third segment, on and on and on until the end of the video. Where video streaming becomes really strong is you can have different streams and different bit rates or different dimensions, and you can serve it all just with the same set of files. So you end up with 3 manifest files to talk about 3 different streams, and those 3 manifest files are controlled by a master manifest file, which is just another text file. And that master text file looks like this, and it's describing the 3 streams that we have, right? 1, 2, and 3. It describes the bandwidth, the codec, the resolution, and then has a link to the child manifest file. Easy enough to understand. I like looking at it this way, because what we can see here is we've got 1.3 megabits per second, 800 kilobits per second, and 500 kilobits per second. So we have 3 different size streams in terms of the volume of data. And we've got different sizes. We've got 720p, 540p, and 360p, right? So we can see exactly what's being delivered, what our options are. And so it's really easy to create these. When you do it with Cloudinary, you just change your MP4 and you turn it into an M3U8, and it does all the transcoding for you. There are a lot of tools on the internet that will do this for you automatically. And all you need to do is upload an MP4 or a movie file or whatever, and it will create the manifest files and all of the stream files for you. Cloudinary is one, but there are a lot of it's really easy to do. In this case, in Cloudinary, I said, give me, these are the different segments, the different resolutions that I want. And I said, full HD, which is giving me 6 different streams from 0 to 5, and then this is the resolutions for all of those, right? So this is just off of their webpage. So what happens when you create an M3U8 file and you put it in the browser and you just hit go? In Chrome, it downloads the M3U8 file. In Firefox, it downloads the M3U8 file. Do you remember who created HLS? It was Apple. So it plays in Safari. And then in Edge, it downloads. So to make this work, you need to have a video player. And the video player is just JavaScript, and there are a bunch of them. 3 of the more popular ones is HLS.js, Video.js, and the Shaka player, which is from Google.js. The Cloudinary, the video workshop I'm giving is going to be supported by Cloudinary. All right, hence all the Cloudinary stuff here. So you've got a player, you download the JavaScript, you say, you know, here's my play, and make it go, and it plays. Players are not responsive by default. And so what does that mean? If you have a different size screen, so if I have a screen that's 720 wide and a screen that's 360 wide, what video is it going to download? Is it going to download the 720, the 540, or the 360? Which video files will it download? And it turns out when I tested this, I had a 1080p version as well, so 1900 by 1080. And you can see that HLS and Shaka downloaded a huge, this one's 14, 15 megabytes. Video.js downloaded 8 megabytes. When I go to a smaller size, HLS.js and Shaka downloaded the same amount of data. You'd expect with a smaller screen, it would pick a smaller resolution. These players by default are only looking at the network speed and not at the size of the screen, which is unfortunate. Video.js drops down to a smaller size video. It's responsive by default. So in HLS.js, they have a parameter you can add to the player, which says cap level to player size, right? If the player's 360, only serve the 360. But it's false by default. You have to turn it on. If I turn it on, do I have that slide? Come on. I think I ran out of slides. All right. Part of the fun of creating a deck in real time. All right. So we'll just skip ahead to that here in this deck. It's thinking it'll come. All right. When I turn on the responsive attributes, the HLS drops from 14 to 4. Shaka drops from 15 to 1, right? You have to turn them on, though. And since they're off by default, most people don't know to turn them on, and they don't know that they're just sending crazy amount of extra data to the mobile phone. The other problem is if your width is only 360 pixels wide and you're sending 1900 pixel wide video, like your phone is working really, really hard to shave off all of those extra pixels to get it into the screen. So why is video startup so slow? Most of the time, you start with the lowest bitrate video. And the reason you start with the lowest bitrate video is it's going to start up faster, right? Smaller video is going to start up faster. You know when you're watching a video stream and it's really pixelated for the first 4 seconds, it looks really bad. The player then can decide, I've got a better network connection and go to a higher bitrate. So usually about 3 or 4 seconds in, the picture sharpens. And that's what we see when we watch Netflix and other products like that. I've seen websites that start with a really, really high bitrate. That's not going to play. It doesn't even play sometimes on desktop. So the player's like, it's not playing. What do I do? What do I do? What do I do? Oh, I go to the lowest bitrate. And then you go to the medium. Well, you just added this really time-consuming step at the very start of the video play. You're losing customers. That's a bad thing to do. And then this is sort of what Amazon does. They use the Goldilocks approach, not too big, not too small. They pick something right in the middle. It takes a couple seconds longer for the video to start, but it looks sharp from the very beginning, so that's kind of cool. And we can use web page tests to visualize this. When you start with the lowest bitrate, the video started playing 11 seconds in. When I do the highest bitrate, it takes 17 seconds for the video to start. And this quality is just as bad as this quality right there. It just took 6 seconds longer. And then here in the middle, this is a much higher quality video. It took 2 or 3 seconds longer, but it's higher quality. That's all of that written out. I mentioned this before. Here's a video stream that separates the video and the audio. And that's neat if you have dubbed tracks. If you have it in Ukrainian and English and Spanish, you can choose it based on the language of the browser. And then finally, just a quick case study. Here is a TED Talk that I was watching. And when I watched it on a 3G connection, I started at this high bit rate, and I dropped to the lowest bit rate video. And I watched it at this really blurry, low-quality video for the entire video. And I was like, the stream I was watching at a rate that was this high. So there are about 5 streams that should have been able to play. And I couldn't figure out why they weren't playing. So I opened up the manifest file. And it starts off playing 1.4 megabit per second video. I'm like, all right, that's probably okay. That should play. But the video is actually encoded at 600 kilobits per second. And so they're doing that so that the buffer fills up twice as fast. If the buffer fills up twice as fast, the video won't stall. Of course, I was getting really crappy quality video, so like that's not ideal. So what I did is I rewrote the manifest file 600, 600. This might stall more often, but I'm going to get higher quality video. The first thing we see is if we look at the y-axis, I'm on a much lower axis now. I start testing. Have you guys watched TED Talks? Like, they're pretty awesome. This is the intro. And the intro, so you can see this is the intro, and then this is the actual TED Talk. So the intro drops to a low quality, but then it quickly recovers, and by the time the video starts playing, the part we care about, it's pretty good quality, right? It creeps up quality back to the original quality. But why did it drop to this low quality at the beginning in the first place? And I wanted to figure that out. So I went to the child manifest file, and you can see here's the intro. There's 3 requests for the intro. The first segment is 5 seconds. The second one is 6 segments. The last one is 0.12. And I played around with the numbers. I tried to figure out what was going on. I couldn't figure it out, so I said, to hell with it. We're going to download the intro in one request, and then we're going to watch the video. And when I did that, I stayed at the high quality for the entire video. And actually, by the time the TED Talk started, I was at a higher quality video than when I first started. So I improved the streaming. Now, it might stall more often, so we should go back and look at that. But you can improve just by playing around with some of the things in the manifest file. You can improve the streaming of your videos. So I don't know if this is going to play out loud. I think I turned my sound down. But favorite movie of my childhood is Ghostbusters. In this scene in Ghostbusters, yeah, my sound's off, so sorry about that. But in this scene, he's warning all of the other Ghostbusters to not cross the streams. Because if you cross the streams, it will mean the end of the universe. Total protonic reversal. I don't know how to say that in Ukrainian. So here's a web page downloading 2 TED Talks at the same time. Right? So if you're streaming and you're trying to maximize the bit rate and you have this much bandwidth, if there's 2, they get half the quality each. So you've got 2 videos downloading that don't look nearly as good. And why would you stream 2 videos at once? You can't watch 2 videos at the same time. It doesn't make any sense. So you should only stream 1 video at a time when you're building a web page. That sort of makes sense. But just to prove that the internet is the internet, this web page has 24 simultaneous video streams on mobile. It doesn't work. These are always spinning because the CPU of the phone just can't handle trying to stream 24 videos all at once. I blew through 245 megabytes of data in 4 minutes trying to get all of these videos to play all at the same time. So why does Facebook generate so many of the requests in the data set I was using? You know how you can embed your Facebook timeline on a web page? And you scroll down and oh, somebody put the Facebook timeline on a web page. I'm not going to scroll through that. On Chrome, if there's a video on your Facebook homepage and you've embedded that on a web page, Chrome downloads all of the video. And it doesn't happen on Safari, so it only happens with the Facebook plugin on Chrome. And it's been around for about a year, and they're not fixing it. So it's just crazy amounts of extra data. Granted, Facebook's paying for it, so it's not really, but it could slow down your web page a little bit, so you should think about that. Video files are really big, and we should really think about, if you have an image on a web page, you can get away with a big image, but you should optimize those as well. But if you have a video file, big video files really screw things up really, really quickly. So you should resize your videos by quality, bit rate, and dimensions. If the video is going to be hidden, you shouldn't download it. You should avoid preload equals auto. Strip out the audio track if it's silent. Don't duplicate video traffic. Start at the lowest bit rate for faster startup. The Amazon approach is sort of that middle bit rate. Your video streaming player may not be responsive by default, so test for that. 1 video at a time, and then just look at what you're doing. Audit your web page once you've built it to see if it looks good, and to see if it's fast, and to see if it's not blowing through crazy amounts of data. And so with that, remember to respect your mobile user's data plan, and thank you so much for listening. I appreciate it.
Thank you, Doug. It was really nice talk. Thank you. Guys, do you have questions to our speaker? No one? Okay, I have just only one suggestion. I have seen that you showed us on the very first screen that it's very sorry, it's not so. Okay, Sorry, guys. Okay, let's keep. Thank you. Have nice to see you here. I know that you have a wedding anniversary in today's island.
Yep.
I think it's worth additional portion of applause. Okay, guys, let's do a small break for 5 minutes, and we will back.
Awesome.
Questions? Do you have
a question?
You have a question?
Yeah.
Oh, okay.
And I'll be around too. So, but yeah, go right ahead.
What you propose to use when you have an audio stream?
When you have an audio stream, in terms of format?
Player.
For a player. So you can just use HTML if you want to. Like you can just use HTML5 player. That'll work. A lot of these video players will work as well just for audio streams. I haven't done a lot with that, to be honest with you.
Thank you for the talk. You have mentioned the Android at the beginning of your talk. Is there some big difference between the approaches of optimizing the media on the native apps and on the web apps?
No, not really. Like the biggest problem is just getting it over the network. I think the biggest delay is always going to be just trying to download a giant file over the network. So look at the screen size of your Android. I mean, if you're building for Android, you're probably okay. You know, you have a better idea of the different screen sizes, whereas the web could be a TV, it could be a computer, right? It's a little bit easier. I mean, obviously, there's still a lot of sizes for Android. But yeah, you just have to look at the screen sizes and the bit rates and the delivery methods. The EXO player is actually a really good player on Android. It does a really good job of adapting the bit rates from what I've seen.
Thank you.
Of course.
Anyone? Okay, thank you. We will do a small break for 5 minutes. We also have some stickers here on the shelf, if you want. Our next speaker. Stas, today we'll talk about CSS properties. You know, it's not the things that we are using a lot on our projects. That's why it's really interesting to hear from Stas about his experience. Please welcome Stas Gavrylov and CSS properties talk.
Hi, everyone. Do you hear me well? Do you hear me okay? Okay, thank you. First of all, I would like to... 1 second. How about now? Better? Okay. First of all, I would like to thank the organizers for taking over the React Kyiv meetups and gathering us all here and allowing us to hear such amazing talks as the previous one. I hope this tradition will keep going. So, my name is Stas. I work at Rails Reactor. Some of you may know us. For those who don't yet, we are a software company with great family culture, lots of perks, and tons of interesting people. We also host Meetup Tonight events, so if you're interested in software talks like this one, please come take us visit. And as for my today's topic, the talk is called Enhancing Your Apps with CSS Custom Properties. First of all, I would like to ask you to raise a hand if you have heard of CSS Custom Properties at first. How many of you? And now, please raise a hand if you use them in your everyday job. Okay, so I believe that this topic will be quite of interest for you. Well, why did I choose this topic beforehand? Today, the interfaces, as front-end goes on and evolves, the interfaces that we build become increasingly more and more complex. And every customer wants to have the sexiest UI possible, and they want everything dynamic, everything moving on the page. And I believe this is the ideal web page in the eyes of any customer today. As it turns out, CSS, making this dynamic, adding it to your applications, is not that easy. CSS in general is quite a complex language. Unfortunately, not every developer thinks so, and most of us, to be honest, end up after learning some basics of the language and do not dig deeper in it. And when JavaScript developers encounter any complex problems with styling that they don't know how to solve with regular CSS, well, what do? They try to solve it with JavaScript, right, as any other problem. Well, because of this, we now have over 50 different solutions according to this link with different metrics and comparisons of performance for CSS in JS. You probably know about this topic, heard of it before. Personally, for me, it never clicked, and I have 3 issues with this approach. First of all, CSS is not a concise language. So when you start putting all your styling as well as the business logic in the same file, it grows quite big. I personally tend to keep my files not as large as possible, but as you can see here, it's a simple example from the most popular CSS and JS package, style components. It takes 15 lines to build a simple button, and you know that complex UIs will have much more stylings, several hundreds of lines of CSS, that's for sure. Well, it turns in the end in such a file that after printing would end up in something like this, with tons and tons of pages of code just for a rather complex styled component with CSS and JS in the same file. The second issue which I have with CSS and JS is that we were constantly told until a couple years ago that we should separate logic from presentation. And now, if we start mixing it together, you get your styling spread all across the application. Well, you either have, if you choose CSS and JS, put everything in JS now, forget about CSS as well, or it will be quite hard to find where was this problem property set, or where was that property set, in CSS or in JS. So it gets all pretty mixed and messed up. The third issue that I have that is, well, I believe that if you can do something natively, you should try first do it natively without adding extra unnecessary, probably, tools for the problem. And CSS custom properties allow us to solve lots and lots of problems that CSS in JS approach tries to solve, but it's a native solution implemented in every modern browser. If you are blessed enough to not support IE 11, you can use it freely. It works like charm. I tested it personally. If you do need to support IE 11, you can still use CSS custom properties for static stylings with the add, I believe the last rows do not see this link well. I will post my slides later, don't worry. You can use post CSS custom properties plugin to at least convert your custom properties to normal colors, normal values after post-processing them, and with this you could easily start introducing them in your code base as well. When you drop IE, you can switch them without any plugins. As you can see, the first public draft of this technology, of this approach, was introduced in 2012, over 7 years ago, and you see lots of people in this room haven't even heard of it before. And that's a shame, I believe, but I do not blame it on you. It's just an overall not so high interest of JavaScript community in CSS. Starting from 2015, this feature is available in Chrome and Firefox, so for a pretty long time you could have been using it. For those who did not read or hear about custom properties before, here's a quick primer. Basically, what custom properties are. You can also hear the name of CSS variables in general, because basically this is how you use them. So I will be changing these terms. I will be using these terms interchangeably. You can set any variable as a property name if you prefix it with 2 dashes in the beginning on any selector and all, and this property can store any value that you could normally have in CSS property. You can set these custom variables either on any normal selectors like this one, ID or class or whatever, or you can set them as global variables on this root selector, which corresponds to your document element, HTML tag. And to use them, the variable in any other property, you should use the var function. You call it with the name of the property itself, and you will get the value that is stored in this variable. The coolest thing is that you can use the var function inside any other function, like calc, which is also, if you don't use calc, you should start immediately. Also another awesome feature to build complex UIs, and maybe linear gradient or any other property, basically. I hope everyone sees this line, but basically if you pass the second argument to var function, it will be used as a default value if the initial variable is not set. So in this case, if we don't have dynamic color variable available here, we will be having white color in the end of our gradient. Unfortunately, not everything is possible with CSS custom properties. If you take a closer look at this example, you can see that I'm trying to store another function as a custom property, and this function uses another variable which is not declared at the same selector. The variable tilt angle is declared on another class which tries to use tilted gradient custom property as its background image. So in an ideal world, this function would read the value of tilt angle from the class, and well, this whole gradient will appear on your screen. unfortunately, this does not work like this because, first of all, it's CSS, right? We have cascade, we have scoping for custom properties, but they do not, like in JavaScript, you do not see local variables from the top, right? Because this variable tilt angle is not declared on the root element, the value of tilted gradient is calculated before it is passed down. So since it does not have a necessary value in here, it will not be visible at all. But there is always a solution. You can, instead of providing a default global variable like this one, you can use any selector, asterisk, or provide a special class which you will have to add to the element where you want to use this gradient, for example, variable. And in such case, because we have all selector here, it will be available to this class as well, and to any other element in your application. I'm not saying that this is the best practice, but this is just kind of one of a way to deal with them. It will be available to the element with tilted class as well. Second. Well, this is it for the theory, and now a couple of demos. So I try to show you them better. The first one is tilted gradient. Do you see the code well? I hope. So if you take a look at the CSS first, this CSS is self-contained. It means that all what is necessary for displaying the gradient on the right is declared in here. We have this linear gradient function. We have a tilt angle variable that we want to use, but if you don't have it, we will use the default value of 90. Also, do not forget that if you work with integer values in calc and you want to use it in any other function that expects not an integer, but for example a degree unit like this one, you will have to multiply it by a unit necessary. And we use this gradient variable as a background for the div on the right. You might have noticed that I haven't yet tell a word about React in general in this topic, right? But this is React Kyiv in the end. Well, it turns out it is very easy to start introducing dynamic to all of this and to start working with custom variables from your JSX code. Basically, all that you need is style tag and pass in their object with value of the variable you want to declare and to pass to the element itself. Don't forget to put quotes around, because this is not a valid key for the object, of course. And in this demo, I have a simple input of type range. This is an integer input with values between 0 and 180, and on every change it sets the value of the range in state, and I pass the angle value as a custom property. I want to remind you that this is vanilla CSS and React, no preprocessors, no CSS in JS. And so when we start moving this range, it dynamically and very quickly updates your view. So this is one of the ways to use it. My demos today are mostly experiments. I'm not saying that they will fit all your needs, but I encourage you to experiment with them on your own. I was also told that not every one of them, for example, works on Windows, but still, I think you can find workarounds for it. The second demo that I want to show you is custom themes. Lots of use cases for CSS in JS, for example, mentions theming of your applications. And again, I would like to start from the styling. In this demo, we have two default variables for the colors that we will be using on our root selector. We also have a container class, which wraps this structure, that has its own two variables for font color and background color, and we use default values for them in the beginning, and we use these variables like font color and background color in the properties of the elements themselves. Well, I have an RGB component here, which also shows a couple of strategies of working with custom variables. First of all, if you want to read the value of custom variable from your CSS in JS6, you should call window get computed style method with the element that you want to read the styles from, and then on receipt object call get property value method with the name of the variable itself. So we will have the color in here. After this, I set these default colors read from CSS to state. Unfortunately, these two color inputs do not reflect from start the values that I need, but it can be because they are basically default browser inputs. But of course, if you replace them with any other element displaying your color, they should work fine. And on the bottom here, I have this RGB container where I will try to override the font color and background color with the values from the state, which by default contain my default variables from here, I remind you. A bit below, I have two inputs of type color, which on every change returns you an RGB value. And on every change, I update my state with the color of the value. And so if I start changing the colors in here, I can easily change the background and the font, for example, and this will be updated instantly in real time. Another use case for the variables as well is predefined theming. For example, I have here a select with a couple of themes predefined, and in my styles file, I have provided two themes that if my container will have a brown class, then I use these variables. If I have a blue class, then I use these variables. And so if I start changing my themes, I have to use important here because previously I have set inline variables on RGB element, right? So I have to override the specificity. By the way, the specificity of CSS is also included, right, for these properties. But basically, this is a way of providing themes in advance. The last example in this demo is called HSL. So this component uses not RGB colors, but hex color. And if you ever worked with HSL function, which is an analog to RGB function, but it takes the value of color or hue as an integer number, and then the saturation and luminosity, you can build quite interesting themes based on the single value. In here, I have a variable of theme hue. I have three other variables which contain HSLA functions based on the theme. So normal will have saturation of 50%, lighter color have higher saturation, and darker color has lower saturation. And all of this depends on a single theme hue variable. In my component, I also have, again, input type color and a couple of helper functions that convert RGB color to hex. And now, if with the help of this one input color, I can easily change the theming of all my apps. So basically, if you build your theme around these gradients, it can be very convenient to rule all of them in just a single place by changing the hue of your color. The last theme, the last demo, sorry, that I wanted to show you is called Stack. This is like a prototype of the component I been building on my current project, and the component itself is basically a stack of cards. So this is a stack component. If it does not have any cards in it, this is a simple card, 200 by 200 in here. If it has several of them, the underlying cards should be placed on the bottom and stick out a little bit. And on hover, they also stick out a little bit. And the green border in here shows the border of the container, because if you can imagine how you would do it, you would have to absolutely position these cards under the bottom one, but when you use absolute position, the elements are taken out of page context, and they would not affect the width of the container. So, if we first take a look at the styles of this component, I tried to move as much styles as possible to the variables. For example, this card size contains a value of length of one side of this card. I can very easily change it, and card size is the base for lots of other parts in this component. Like, for example, card shift, the size that card sticks out when you when there are more than one is 1/10. For example, I can change it to 1/5 or 1/7. Animation style is here just for the convenience of reusing it. The size of the container itself, as you could see, is calculated by multiplying, by summing the size of regular card if you don't have any underlying cards. So it's also 200 pixels, plus the value of our shift, how far the cards pick out, multiplied by the size of the stack. And we don't see the size of the stack declared anywhere in here, because I can easily pass the size from the component itself. This is the code for the component. It basically takes the single property, and we pass this the size of the stack as a value to our container to effectively calculate the necessary width. And in here we build an array of the same divs, and we can very easily provide an index property, which is quite useful if, for example, we think how far should we put this like second card on the bottom, right? It's very easy to calculate the offset for any card if we just use its index and multiply it by the card shift that we have in here. So with this combination of a bit of JavaScript and a bit of CSS, we get this pretty interesting dynamic component, which still has all of its properties. I mean, the dimensions. It affects all the sibling elements on the page, and allows you to build more complex interfaces. A couple of links in the end. Basically, the first three are different articles which I recommend you to read from Smashing Magazine. The last one is MDN link and general practices for working with custom properties. And that's it. Thank you.
Thank you, Stas, for great talk. It's really amazing how many things you can do now with just a pure CSS.
Yeah.
Guys, do you have questions to Stas?
Hi, thank you for your talk. Could you tell, please, what kind of values do you usually put in your CSS custom properties in your everyday work?
Well, first of all, the indexes, like in the last example, because it's useful to know what is the, if you have lots of sibling elements on one level, useful to know like what is their position in the container. Also, I'm recently started diving deeper in CSS grids, so it's an awesome feature to provide the size of your grid, for example. If you know how many items your container takes, you can easily say that the grid size is, let's say, 10, for example, and you will have instantly the grid of the size you need. I'm not using the colors as I have shown here, but it's just another way to think about them. So it's basically there are unlimited ways to use them. Just as I was heading to this meetup, I've seen that there's a new article on CSS tricks about using Boolean logic in with CSS variables. So I think this topic will be evolving, and we'll soon see a lot more interesting examples.
Thank you.
Thank you. One more question. Could you compare CSS custom properties and SAS or CSS? What is the better? Because I think the same problems can be resolved by SAS, and why CSS custom properties is better?
As far as I know, you cannot dynamically set SAS variables, right? And this is the biggest feature for them, personally, for me. If you use them only as static values, if you support older browsers, yeah, there's probably no difference, and you can. But I would still start integrating it now, because in future, when you, as I said before, when you drop older browsers, you can fully use all the possibilities like dynamic styling that they provide.
And one more question. For using CSS custom styles in React application, you have to use inline styles for React components. As I know, inline styles for React components, it's not best practice.
Well, I personally take this approach of not trying to optimize anything if it works fine, right? You know, until you encounter any performance drops, you should be fine with this. Well, there is no other way, unfortunately, to dynamically update anything, so you have to trade something. In my case, that was a perfect trading.
Do you have performance problem?
No. I even I usually test my apps with 4 to 6 CPU slowdown. You know, Chrome allows that, and everything works perfectly fine.
Okay, thank you. More questions?
In CSS variables, it's not allowed to use their values as media queries.
Yeah, this is correct. I forgot to mention that. As of now, you can only use them as parts of other properties. So media query is not a property itself, right? But as far, if I'm not mistaken, the next level of the specification will allow to use custom properties in media queries as well. It's not here yet, but I believe in future it will be available.
It's just interesting. Have you any common solution for this dynamically?
Well, if you build your styles around the variables in the beginning, the only thing that you will have to change in your media query is the values of the variables themselves, and the rest of the app will be styled automatically. So this is another great feature, I believe.
Okay, thank you. Thank you, Stas.
Thank you.
Guys, right now we will do one more break for 10 minutes. Let's say, let's come back here at 8:25. We have some food there under the tables. Please sit. We are continue. Before we continue, I want to say that our today's host, Wix Engineering, is looking for junior developers. If you know someone or it's your friend, just say, in 1 or 2 weeks, Wix Engineering will announce about Kickstart program. You know, it's a program for junior developers who hasn't a lot of experience and just watching for social networks or ping me after the meetup. I will say a lot about this program. Okay. Let's continue to our meetup. The next our speaker is Nastya, and Nastya will talk about typings. It's a really close topic for me, and it will be interesting to listen. Please welcome. Please welcome.
Okay. Hello, everyone. Can you hear me well? Okay. My name is Nastya Mashoshyna. This here is me. Okay. Like that? Uh-huh. I'm front-end developer at Levy9 and a mentor at Kotans, and this here is my very first public talk ever. I'm pretty nervous, so I promise it's gonna be quick. Typings. So the story goes like that. A few months ago, I have started my first project with React and TypeScript. As for TypeScript, previously I had experience of supporting an existing Angular 4 project, but the project was rather old and written before I joined, so as for starting a new project from scratch, this was definitely a very new experience. I was preparing myself by reading the documentation, by going through some Egghead courses and lots of articles. And at some point, I realized that there was something that bothered me. I could find, the thing was that I could find really a lot of the how of TypeScript, but not the why of TypeScript. What I mean by that, that I could find any information about the setup of the project or the syntax quirks, but I couldn't find any explanation of why do I actually need this. Like, okay, I see. TypeScript is a superset of JavaScript, which is compiled, which allows you add types, which is compiled, and the compile time it checks for the errors. Okay, I see. It should allow me to minimize errors in my code. But how do I use it correctly to achieve this goal? So I went around asking my friends and colleagues. I would like to use this opportunity to thank to my team at Levy9 because they probably hate the word interfaces and will hate it ever since because I really I asked them really a lot. Okay, so in this talk, I would like to summarize some of my findings or some of the things that I wish I had been told a few months ago. This talk is clearly targeted at developers who either are only starting working with TypeScript or who haven't yet started but are interested in it. So if you are a seasoned TypeScript developer, you're probably going to be bored for the next 10 minutes. I'm sorry about that. Anyways, the first thing that I discovered was actually that to write, not that. To write proper TypeScript, you actually need to shift your mindset a bit. Namely, you should start focusing, TypeScript is all about interfaces. So you need to start by developing and deciding and designing the interfaces between your code entities, and only then starting the implementation. This approach is rather usual for the developers of in languages such as Java or C#, but probably not so usual for JavaScript developers. However, I think that was a very valuable experience for me, and I certainly can recommend it to anyone. Also, TypeScript provides you with a nice set of tools to do so. You don't need to scratch something on paper. You have interfaces which you can use and see a documentation of your code appear just when you write it. The next thing I realized was that TypeScript is, writing with TypeScript is not about describing the inputs and outputs of your functions. Because my first, at the very beginning, my first impulse was really like, okay, I need to describe every input and output, and that will be okay. Not exactly. What you need to do is to build your own typing system of your application, which in ideal world should actually reflect your domain. Yeah, but most importantly, this should be a system which is tightly connected. The reason for that is that actually the most important thing, in my opinion, the most important thing that you should keep in mind is that you should avoid holes in your typing system. A hole in your typing system is a place in your code where TypeScript, for some reason, loses typing information and allows you to do some mistakes. Your main goal is to keep this in mind and to help TypeScript to help you to avoid mistakes. By the way, thanks to my fellow mentor Ivan Titarenko, who put a lot of effort in explaining those things to me. Let's move on. The next thing was kind of aha moment for me. You probably know, if you heard something about types, you probably TypeScript, you probably know about the types project. It's a collection of community written typings for libraries not written in TypeScript. So you can import those types in your project, and TypeScript will be aware of what to expect of a certain library. What I wasn't aware at the beginning of was that actually you can import the interfaces directly in your code and extend your own types or interfaces from those provided by the libraries. There will be some code in the next slide, so brace yourselves. Let's take a super simple React component. It's a card which shows title. I don't know why you would need this, but anyway, you have a card with one property. You describe it. It has one property title. It's a string. But then, after some time, you decide that you need to add to this card the functionality of leading your user back to the previous page. Okay, this card will be then rendered by Reactor Router Route inside the Reactor Router Route component, and you expect it to have the usual props like location, history, and so on. But if you try to do this, TypeScript will yell at you because it actually at this point has no clue that there is this history prop. What can you do? The first impulse would be, okay, if TypeScript doesn't know about it, then let it know about it. We'll just describe it in the props of your component. But actually, the cool thing is that you don't need to do this because Reactor Router DOM exports an interface called router component props, which you can use and extend your props from this provided interface. This way, your component TypeScript and your component knows that it has a history, location, and so on. Yeah. So the last thing I wanted to mention, generics. Generics are things that at first blew my mind completely, so I had to take some time to wrap my head around it. But trust me, well, actually, when you see something like this, like brackets inside brackets inside brackets, that may seem confusing, but I encourage you to take this time and to get used to using it, but because you really love it, and when you do, then you will try to then you will look for that in all the interfaces provided by the third-party libraries. So just to reiterate, the 3 things I would like you to retain from my a little hectic talk is try starting with interfaces and then start the implementation. Keep in mind that you need to, at any cost, you need to avoid holes in your typing system because otherwise it doesn't make any sense. And check what types does your libraries that you use provide. I would also like to mention and provide link to this wonderful guide, Static Typing Guide by Piotr Kwiatek. It's a really, really long and really, really detailed example of how you can style your React Redux application with many different cases. Maybe you don't need it that detailed, but you certainly should take a look at it. It's a good starter. That's it. Thank you very much.
Thank you, Nastya. Just wait a second. We have questions for you. Wait a second. Thank you for a great talk. I really think that 2019 is good year to start to using typings in your applications. By the way, how many of you already use some of type system? Okay, nice, a lot. But I think you should all try this. Either it will be TypeScript or Flow, just use it. Just give a chance. Okay, questions?
Thank you. Have you made a conclusion? Is it worth to use TypeScript in the React application or not? And in what cases it's worth to use TypeScript? And one more question. What problem did you face when you started using TypeScript in the React application?
Well, in my opinion, it's certainly worth doing it. I was one of the developers who advocated for doing so, and we really see that it works. Now I need to move back to some JavaScript, vanilla JavaScript libraries, and I find it really hard actually when you are used to seeing the type information, when you are used to the compiler helping you. Well, maybe it's a maybe it's a bad habit, and it's better to always be like to always not forget doing something. But I find it really relieving that compiler supports me.
Thank you for this short but informative talk, and I'd like to ask about TypeScript versus Flow. I did not have experience with TypeScript, but I had with Flow, and maybe you or your team, what opinion do you have in which projects it's better to use TypeScript, in which Flow, and yeah.
Unfortunately, I don't have own experience working with Flow, and also my colleagues actually, that's like something that is the teams in the company where I work, they mostly use TypeScript, so we have experience and expertise in this, so couldn't say anything about Flow.
Questions?
Hi, thank you for a talk, and my question is about the configuration. Do you use the TypeScript compiler or something else? And what about Create React app? Do you use the eject function or not?
No, we did not eject. We created our application with Create React app with TypeScript. Create React app with TypeScript, and it works fine.
Okay, thank you.
Okay, thank you, Nastya. You really should to try TypeScript or Flow. We will write few applications in our company, in my personal, not personal, in my company's projects, and it really worth it. Okay, while our next speaker is preparing, I want to say that we are looking for speakers here. We will have meetups fully in Russian and Ukrainian languages or in English. So if you would like to speak about something, if you have some experience, just ping us, someone of our team, and we will try to make a choice, to help you make a choice. Okay, the next our speaker is Evgeny, and you know, functional programming could be difficult, you know, and animations by itself could be also difficult. But the next our speaker combines these two words is his topic name, and let's see what happens. Please welcome Evgeny, and just a few seconds, please.
Okay.
Okay.
Let's start. My name is Evgeny. I work in Rails Reactor. Here's my links to my social blah 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 something, and here is the link to this presentation. So if you want to open it on your laptops or phones, it's about the time. Okay. So what is the topic of my talk? I mean, the title is very broad, very huge, so I try to narrow it down to some really specific problem, and the specific problem is to have some fun out of functional programming and animations. So my talk, small disclaimer, my talk is heavily inspired by this book. It's written by Paul Hudak. It's about, in general, functional programming with multimedia, or multimedia with functional programming. And specifically, I will talk about animations, and also a few words that Paul Hudak and Connell Elliott about 20 years ago came up with a nice idea about functional reactive programming. And the idea of functional reactive programming was born out of some functional reactive animation. So it's just usual animation, but interactive. You can click, move your mouse, and the animation will somehow react on your inputs. And 20 years ago, that was like not a huge, but nice. So what I'm trying to solve, I'm trying to do something like that. No interactive animations today, just some regular. And I start with some, I don't know, some pretty basic sprite animation with help of Doom Guy. And this is what I usually do when I try to do something with Canvas. As you can see, there is a lot of boilerplate code. There is a request animation frame and callback loop, and you also see that there is some rules for my animations, some periodic functions, some I don't know, lookup into sprites array. So it's pretty imperative, but it's not bad. It works, and it looks something like this. But the thing is that it's not enough for me. Like, yeah, it works, but then I want to try something else, experiment a little bit, maybe slow animation down, or maybe change some parameter here and there, and I don't want to lose this one. This works perfectly fine, so I start to copy and paste, and those animation functions, they will grow in their number, and the problem is that with small changes like here, you will have to copy all this boilerplate, and that would be nice to have something like this to describe your animations. Just some methods maybe where you specify some parameters, and that's it. So the Canvas API is hidden somewhere in this class. It's abstracted, and you just describe what you want, and then maybe you run it or maybe not. Yeah, so we will do something like that in this talk, and we'll start to abstract. So the first step is to split everything, move, separate, decompose your animation function, and this is what you probably came up as a first step in your decomposition process. Is this really functional programming? Well, not. Even though you define some functions which do some small bit of work, there are a lot of problems with that. The main problem is you still call methods API methods of Canvas inside your functions. Why is bad? Because when you want to try to compose those functions, that means that you basically run them when you call them. So you cannot really defer the animation when you specify, when you describe something. So for example here, if you don't want to run it for now, you just can specify this one part and maybe compose with another animation, and it doesn't really run before you tell. So with this approach, that would be problematic, the deferring of this execution. So also when you try to, when you start experiment, you start with some crazy ideas. What about I want to render it into GIFs or GIFs, or you want to try different environments. You heard that Skia was ported in WebAssembly, so this API also is enabled in your browser. What if you want to create a live coding experience inside your console? So how to do that? And that means that you really have to separate the description of your API and its execution. So here we came up to the idea that to run this code, to run this translate, draw image, and clear rect functions, we need some probably optimized, probably not runtime, but we will pass only the resulting animation description or declaration, and and our declarations will live somewhere else. So how to do that? We'll start design with data types. So we start with here, for example, I use TypeScript. You can also use Flow, but also JavaScript will fit into this idea very nicely. So you have to start your design of your API with data types. So I mean, it's a good approach to start defining types before you actually start to implement something. It would be easy then to use it because after your implementation is done, you don't have to create any declarations, any annotations. It's already done. So there is nothing to cover with types. It's already was covered with types. So it's nice benefit to start the design of your application, of your functions, with data types in mind. And we're going to start with some very specific and atomic actions of our API, graphic actions. So for now, nothing related to animations directly. We just specify some basic actions we want to do with our graphic API to render some static images. So here you can see there is move, scale, object types, and types of objects, draw image, empty action, compose action, what it is, why we use the union type. So this basically is known as discriminated union, means that we have some very broad type which correspond to some concept like graphic action, some action with Canvas API, for example, and it actually can take values of different very specific types. So for example, the move type will contain the information about coordinates, and scale type will contain not type value of this type will contain the scale factor. Draw image will have some information about sprites. I don't know, it might be some name or reference to resource manager. It depends on you, on your runtime. And empty action and compose action, it's to like helper things that will help you to compose those actions. So the idea is that first of all, from those specific actions, you can compose some kind of tree, some nested structure, and it will also have a graphic action type. Why we do that? Because for our runtime, we will have to parse this structure back. And yeah, so this will look like this. Here you see some imperative, right, API of Canvas, and this is how it can be presented with those types. So looks like some abstract syntax tree, I don't know. And yeah, after that, what we have to do, how we can work with those types, we will define our functions, finally, like move, scale, draw image, and what they will do, they will just construct the values of some particular types in this graphic action union type. So if you remember on previous slides, there were directly Canvas methods calls, and here we just return the values of graphic action type. And one of the interesting functions for me is this and then, which allows you to compose your actions. So using this function, passing values of another graphic action, you can compose. And this is nice, I think. So how our runtime will work? So runtime is just a function which try to match the the animation value, no, not an animation, graphic action value, and it tries to check its type, and it will handle it differently. So depending on the type of the object, we can perform some actions, and then just run it. Run graphic, pass some canvas context if you need it, and this is our program. This is what our declaration. This variable contains our declarations. So, animations. How we can define the animation? Also, we can think a little bit about what the essence of animation might be, and in terms of graphic action. So, it's just a series of graphic actions which happens over some time. So, basically, it's just a function which gets the time and returns type graphic action, for example. Time is just a integer, just number for now. And yeah, this is the interface of this animation type, and this is generic type, as you can see, and it doesn't explicitly say that animation function should return graphic action type. It was done so we can create different kind of animations. For example, we can animate the change of some numeric value. So it's not really an action. It's more like, you know, like a signal in I don't know, in physics. And this is actually represents this idea why we should even concern about it. Also because we want to change over time some parameters of our moving or scale action. So this is done for those purposes. And we don't need to modify our previously defined run graphic, because we will extend the context of our runtime with animation. So we will define another function, run animation, and that's just it. We just put it inside the loop function, which we defined on the first one of the first slides. But you can clearly see that first of all, it's much nicer, and also you can see that there are no specific to our animation logic. So you just pass the animation, you run its composed function, and as a result, you just get the type graphic action, whether it would be the draw image or compose action with draw image and moving. We don't care. The run graphic will parse this value for us and do something in a canvas. So we cannot use, obviously, the functions defined for graphic actions. We need to define our own scale, move, draw image functions to operate on animation type. And there are two ways how we can do it. We can specify for each corresponding function defined graphic action type and return the corresponding animation. Or we can use some helper functions which will do this for us kind of automatically. So this is called lifting, and this is how it actually looks. So pretty generic function which gets some function from, I don't know, A to B, and some already constructed animation value, and return as a result another animation. So basically the same as we define for function scale A, but more generic. So we don't need to specify like 10 functions. We just use only a couple of them, and then we kind of lift our simple functions to the functions which operates on animations. That's easy, I think. And how to use it? So the same way as we used for graphic actions. We just call those already lifted functions, and also the nice thing is that it's also kind of deferred. So this animation is already defined. We created this tree of objects, but we didn't run anything. And we also can even improve our code. If you can call this improvement, we can hide some of this stuff inside animation library class and provide it with chaining. So basically, the chain would be the same as and then function, which will compose the animation returned by this method and animation defined here, and also returns the animation, and also we can again compose it with scale, and that's basically it. And after that, just run it when you want. So I don't know, it's pretty nice. I mean, it's way better than we defined it on the previous slides. So there is also a nice thing that some of those abstractions they can be reused even in different contexts. So, for example, I saw recently an article with a guy who animated emoji in address bar, and I tried to do the same using the approach I described earlier. So I defined it also my time emoji action, which just has a single character and composed character. I didn't add all the code here, so just believe me that there are also defined functions to construct values of those types, and there is the runtime for it, which will parse every single emoji action or transform, and we'll run it, and the action just, I don't know, append to location hash. So the animation will look something like this, and this is how it will define it. This is I think it. This is what I wanted to share with you. So a little reading list, Haskell School of Expression, original paper about functional reactive programming, and a few inspiring things just to maybe, if you're interested, to dig into functional programming. Thank you.
Thank you, Evgeny. Actually, functional animations wasn't look so scary as I expected. It was cool. Guys, do you have questions? Anyone? It was really clear, I think.
Nice.
Thank you. Okay, guys, our today's meetup is going to be finished. I want to say many thank you for all of you, for your attention, for your questions, and many thanks for our speakers today. Remember, we are looking for speakers for the next meetups, and it will be glad to see you the next times. Thank you.